There are situations where you have an index, but you still experience performance problems. Let's look at one of the common scenarios. So I'm going to select the customer ID column from the customers table where state equals California or points is greater than 1,000. So in all the previous examples, we used the AND operator, but here we're using the OR operator. Now, let's explain this query and see what we get. So, just like before, here are the possible indexes, and you can see MySQL has used an index to satisfy this query. But look at the number of rows. That's 1,010. It looks like we have a full table scan, but actually we don't. Take a look at the value and the type column. That's index, which means we have a full index scan. This is faster than a table scan because it doesn't involve reading every record from the disk. Having said that, we still have to scan 1,010 records. So how can we optimize this query further? This is one of those situations where you have to rewrite your query to utilize your indexes in the best possible way. In this case, we're going to chop up this query into two smaller queries. First, we're going to select all the customers located in the state of California. Then we're going to union that with another query that picks customers who have more than 1,000 points. So let's break this up into two smaller queries. Here's the first one. Then we union this with another similar query, but with a different where clause, like this. So this index that we have satisfies the first part of this query because with this index, we can quickly find customers located in California. But this index is not an ideal index for searching customers by their points because points is the second column in this index. So if we use this index to satisfy this query, MySQL has to go through every state and then pick customers who have more than 1,000 points. So to speed up the second part of this query, we're going to create a separate index on the points column. So on the top, create index IDX underline points on customers on the points column. All right. Now let's see what happens when we explain this query. All right, now in this table, we have 3 records. The first 2 have an identifier. 1 represents the first select, 2 represents the second select. For the first select, which is our primary select, here are the possible keys. And as you can see, the composite key on the state and points column is picked. So with this index, we have to scan 112 records. Now for the second select, once again, we have 2 possible keys. One of them is our composite index, and the other is the index that we just created on the points column. As you can see, MySQL picked the last index because this performs better on the second part of this query. So with this index, now we have to scan 528 records. So if we add these two numbers together, we get 640 rows, which is a significant improvement compared to the previous query where we used the OR operator. Previously, we had to scan 1,010 records. Now we have to scan 640 records. Let's look at another example. I'm going to select the customer ID column from the customers table where points plus 10 is greater than 2,010. Let's explain this query and see what we get. So once again, we have an index scan. Look at the number of records. That is 1,010. So we have a full index scan. Even though we have an index on the points column, MySQL had to read every entry in our index to satisfy this query. Now here we have only 1,000 records. That's not a big deal. But if you had 1,000,000 records, even scanning every entry in an index can be slow. So what is the reason we have a full index scan here? That's because of this expression. So whenever we use a column in an expression, MySQL is not able to utilize our index in the best possible way. So to solve this problem, I'm going to isolate this column and rewrite this expression like this, where points is greater than 2,000. So this produces the exact same result. But now when we explain this query, we see something radically different. Look at the number of rows. It's only 3. This is a huge improvement compared to the previous query. So if you want MySQL to utilize your indexes, you should always isolate your columns. Next, I'm going to talk about using indexes for sorting.